Okay. So last class we had implicit differentiation. Related rates is going to use that method again of implicit differentiation, but this time instead of deriving with respect to x, we are now going to derive with respect to time. So now x and y are going to be implicitly derived with respect to time. And this is the way related rates works. For example, as you see there, a seasonal product such as winter coats, the price y, and weekly sales will be related by a demand equation, and both price y and quantity x will depend on the time of the year. So when we do related rates, x and y are now depending on time. So this is why we will derive with respect to time. And with that being said, I'll get to the steps in a second. I just want to go over some notation. So last time we had the derivative of y was, the implicit derivative of y was y prime. But now since we are deriving x and y with respect to time, we're going to have the derivative of x with respect to time, which is x prime. And we're going to have the derivative of y with respect to t, which is going to be y prime still. So the book notation or the My Math Lab notation, x prime is going to be seen as dx over dt, and y prime is going to be seen as dy over dt. So whenever you're typing in your answers, if it doesn't take x prime or y prime, you'll type them in as dx over dt or dy over dt. So just to clear up the notation, depending on what My Math Lab wants. I like to stick with x primes and y primes because it's just a lot neater and less messy notation wise. But just know that they both mean the same thing: the implicit derivative of x and the implicit derivative of y. Okay, we may even come across other variables such as dp over dt. The derivative of p with respect to t will be p prime. So if we see that in a problem as well. Okay, so now when we solve a related rates problem, we determine the quantities that are changing with time. We find an equation that relates these quantities. We differentiate both sides of the equation implicitly with respect to time, substitute any given values into the derivatives, and then solve for the remaining derivative and interpret your answer as a rate of change. So to keep these steps really simple, to solve a related rates problem, just work with the given information and do not plug anything in until the very end. So we don't plug anything in until the very end of the problem. Okay, so the first two examples are just going to be practicing how to apply the implicit derivative with respect to time. So number one says, let y equal x cubed minus 3, and we're given that x prime is -2, x is 2, and I think that's it. Yeah. And it says find y prime. So here's what we're going to do. Just like we did last class, we are going to do just a little different, of course. We're going to say d over dt of y equal to d over dt of x cubed minus 3. Now we're taking the implicit derivative with respect to time, and the implicit derivative of y is going to be y prime. The implicit derivative of x cubed with respect to time is going to be 3x squared x prime. And of course, the derivative of 3, no matter what, the derivative of a constant implicitly or not is always going to be 0. So there is our implicit derivative with respect to time. Any questions on that?
Where did the x prime come from? I mean, because I'm reading it and it just says x prime equals -2 when x equals 2.
That's coming up next. So those are the given values. So remember, we just found the implicit derivative, but now we're going to evaluate it given these values. Cool?
Okay.
So we're going to say y prime evaluated when x is 2 and x prime is -2. So this means of course, you'll plug x in for x and x prime in for x prime. So we're going to have the evaluation equals 3 times 2 squared times -2. Good with that? And then just multiply everything together. 3 times 4 times -2, so that's 12, that's -2. We get -24. There you go. So when we deal with implicit derivatives with respect to time, the problem is going to say either solve for y prime or solve for x prime, and then plug in the given values afterwards. Any questions on this one before moving on?
So just to clarify, all we did is the first equation that came out, we pretty much just simply plugged in the 2 and the -2 where they belonged, where the x and the x prime, and we just
Exactly.
solved for that.
That's it. That's it. Cool. And that's why we don't plug anything in the beginning. You always plug in at the end. Okay. I guess a quick note on if you were to type this in my math lab, let's say it didn't take the primes, then the way you would type your answer is dy over dt equal to 3x squared times dx over dt. So this could be the possible my math lab answer. Again, I just stray away from the notation because I think x prime and y prime just look a little cleaner. But just know that they mean the same.
Okay, and if it counts us wrong, we can always just let you know too, right?
Exactly. So you can always leave comments when you upload your work like, hey, I used x primes and I forgot about that, but I can look at your work and be like, okay, I can give you credit back for it.
Okay, thank you, sir.
Mm-hmm. Okay, let's try it again. Evaluate x prime for x squared minus 2xy minus y squared equal to 25 with the conditions y prime is -1, x is 2, y is -1. So what we're going to do here is take the implicit derivative with respect to time, and we're going to solve for x prime. So it says evaluate x prime, which means we're going to solve and then evaluate. So we're going to say d over dt of x squared minus 2xy minus y squared equal to d over dt of 25. Okay. Now we're taking the implicit derivative of everything, but before we start, we're going to come across a little issue here. We have 2xy. So this is going to use an implicit product rule again, just like last time. So this is going to be the implicit product rule. And I'll say of xy. Actually, let's say d over dt of xy. Okay, so let's handle this part first, which means that f is going to be x and g is going to be y. Now remember, we are taking the implicit derivative of both of these with respect to time. So this means that the implicit derivative of x with respect to time is going to be x prime, and the implicit derivative of y with respect to time is going to be y prime. And now, if you finish your product rule, it would be f prime times g, which would be x prime y, plus, oh, forgot my prime on there, right? G prime. G prime times f, y prime x, or, like I said, I like to write it as x, y prime. So if you see that, save this little derivative formula to save yourself some time. Okay, now let's move forward. So first up is the implicit derivative of x squared. That's going to be 2x x prime minus 2 times the implicit derivative of x times y, which we have above, x prime y plus x y prime, minus the implicit derivative of y squared, 2y y prime, equal to the derivative of 25, 0. Okay, and now we are going to solve for x prime. That's what the problem wants us to do. So we're going to solve for x prime. So the first thing we're going to do is distribute this -2. -2x prime y minus 2x y prime minus 2y y prime equal to 0. Okay, so again, we're solving for x prime. So move anything over to the right side that doesn't have an x prime. So who's going to the right side?
-2x y prime and
Good.
-2y y prime.
Good. There we go. So we just moved them both over to the right side. Okay. And now look at all 4 terms. They all have a 2 in front. So we can make our lives easier by just dividing everything by 2. We're just going to reduce everything by 2. Let's get that out of the way. So I'll say divide by 2, divide by 2, divide by 2, divide by 2. And running out of room. So we'll come up here. Oh, that was, sorry. Yeah. So we'll come right here. Why not? So this leaves me with x prime minus 2x prime y equal to, oh, sorry.
Well, no. The x
Sorry. We divided everything by 2, right? Minus x prime y equal to xy prime plus y prime. Okay. And now we are still solving for x prime. So if you look at your left side, we have a greatest common factor of x prime. So what can I do with that?
Factor that bad boy out.
Factor it out. X prime factored out would leave me with x minus y equal to xy prime plus yy prime. And now all we have to do is divide by x minus y. And we get x prime is equal to xy prime plus yy prime over x minus y. There's our implicit derivative solved for x prime. And now we have to plug the numbers in that we were given above. But before we do so, any questions? Also, I'll rewrite it just in case it wants the MyMathLab format. Dx over dt equals x times dy over dt plus y dy over dt over x minus y. just doesn't look right, but it is. Okay, so let's go ahead and evaluate this. So I'll come up here. Let's say, not y prime. X prime evaluated when x is 2, y is -1, and y prime is -1 as well. So this is going to equal, we'll have 2 times -1 plus -1 times -1 over 2 minus -1. So we're just plugging in the given values for x, y, and y prime. All right, the numerator, you'll get -2 plus 1 over plus 3. So our answer here is just -1/3. And there it is. Lots of letters, numbers, primes. So watch your work.
Just a little answer and all that work. My
That's
God.
it. Hey, as long as we get an answer, right?
Yes.
Okay. Any questions on this one before moving on? All right. So now we get into the application problems. So our little word problems. Okay. So 2. Suppose that for a company manufacturing calculators, the cost, revenue, and profit equations are given by cost is 72,000 plus 60x, revenue is 200x minus x squared over 30, and profit, of course, is revenue minus cost. Okay. The production output in 1 week is X amount of calculators. If production is increasing at a rate of 500 calculators per week at a production level of 1,500 calculators, find the rate of increase or decrease in the cost, revenue, and profit functions. Okay, so here is where we actually have to use those steps that were on the first page and label what we're given. Let's find the information and label it. So one thing we see is that calculators is given by X. So we have X calculators. So X is the number of calculators. And then the next thing we see is that if production is increasing at a rate of 500 calculators per week, rate. Well, what fancy word represents rate? It also means slope.
It's that one that we learned. I forgot what it's called.
The derivative.
There you go.
So if this is the rate of calculators, this means that this has to be the implicit derivative of X. So the rate of calculators is going to be represented by X prime. And I'm just going to say rate of calculators. Okay, so we're just putting a label on what our X's mean, and now we're going to put a numerical value to it. So for our derivative, since it says rate, it says that we're producing 500 calculators per week, the rate. So this means that X prime will be 500. And then it says that we are producing 500 calculators per week at a production level of 1,500 calculators. So this means that X is just the number of calculators. So X is going to be 1,500.
Can you scroll down a little bit, please?
Yeah. There we go.
Thank you.
Okay, so now we've put the labels on X and X prime. X is the number of calculators. So we're producing 1,500 calculators. And then we are producing 500 calculators per week, a rate. So that'll be X prime. Okay. So for A, it wants to know what is the rate of increase or decrease in the cost function. So now when we deal with these related rates problem, all we want to do in order to find a rate is take the implicit derivative. So if you see those words, if you see the word rate, that just means, hey, that's a derivative or take the derivative. So what we're going to do with the cost function, which is above, oops, sorry. We're going to say d over dt of c equal to d over dt of 70,000 plus 60x. Okay. And the derivative of c with respect to time is going to be c prime. The derivative of 72,000 is 0. And the implicit derivative of 60x is going to be 60x prime, because it's the implicit derivative with respect to time. Everybody good with that? Which means if we want to find the rate of increase or decrease in our cost function, do we have an X prime value that we can plug in?
Yes, 500.
Yeah. So we'll just say C prime equals 60 times 500. And we should get, well, 6 times 5 is 30. And then just add in the last 3 zeros. There we go. Now, is this result a positive or negative number?
Positive.
Positive. So this means that if we are producing 500 calculators per week, the cost is going to increase by $30,000. Cost will increase. And I mean, it makes sense if we're pumping out 500 calculators per week, its cost is going to be up there. Okay. All right. Everybody good with that one?
Just a quick question. When we're
Go ahead.
finding the derivatives, just because we're doing it with time, you're going to keep like the 60x prime versus just putting 60, right?
Exactly. Because if this wasn't with respect to time, then that derivative would just be cost equals 60.
Okay. Okay. Just want to make sure.
Mm-hmm. But since it's with respect to time, now it's 60x prime. Okay. Now we want to take the implicit derivative of the revenue function, which is up there. So let me erase this, get that out of the way. Okay. So we're going to say d over dt of r equal to d over dt of 200x minus x squared over 30. So I'm just going to rewrite x squared over 30. I'm going to rewrite it as 1 over 30 times x squared. They both mean the same thing. So x squared over 30 is the same as 1 over 30 times x squared. All right. And of course, the reason I do that is so we can see the derivative a little easier. All right, get rid of that. So now the implicit derivative of r is r prime. The implicit derivative with respect to time of 200x is 200x prime minus 1 over 30 times the implicit derivative of x squared. 2x, x prime. Okay, now let's just go ahead and simplify this last term because we can do 130 times 2, which this will give me 200 x prime minus 1 over 15 xx prime. So that 2 over 30 is 1 over 15. Okay, so there's our revenue, or the derivative of the revenue function. But now let's go ahead and plug our x value of 1500 in for x and our x prime value of 500 in for all the x primes. Okay, so we'll say I have room over here, sure. R prime is going to be 200 times x prime, which is 500, minus 1 over 15 times x, which is 1500, times x prime, which is 500. Okay. And I guess I could use Desmos to help type that in. Let's go calculator. $200 times 500 minus 1 over 15 times 1500 times 500. There we go. And we get 50,000. Okay. Back to the notes. All right. And of course, interpret. So is that another positive answer?
Yes.
Yes. So this
Yeah, very
means
much,
that
very much.
if we're producing 500 calculators per week, well, not only will costs increase, but revenue will also increase. Okay. And then profit. So now we want the derivative of that profit function. So we're going to say d over dt of p equal to d over dt of r minus c. And the implicit derivative of p is p prime equal to the implicit derivatives of r and c, r prime minus c prime. Well, this one's great because do we have a value for r prime already?
See?
R prime is 50,000. Do we have a value for C prime?
$30,000.
Nice. 30,000. So the revenue, the derivative of the revenue minus the derivative of the cost function means that profit is going to be at $20,000. Is that another positive number?
Yes.
Yes. So this means that if we produce 500 calculators per week, cost will increase, revenue will increase, and that means that profit will increase as well. Any questions on that problem? All right. Let's do another one. All right. 3. A retail store estimates that weekly sales S and weekly advertising cost X, both in dollars, are related by the equation S equals 50,000 minus 20,000 e to the negative 0.004x. The current weekly advertising costs are 2,000, and these costs are increasing at the rate of $300 per week. Find the current rate of change of sales. Okay. So again, let's just label everything we know. And from the first sentence, we know that sales is represented by S, and X represents weekly advertising cost. Okay. And then the next line says the current weekly advertising costs are $2,000. So that means X is $2,000. And then we say these costs are increasing at a rate of 300. So what label is 300 going to get? Or what variable is 300 going to get?
X prime.
X prime.
There you go. I'll say X prime is just the cost rate. Why not? Rate of cost, cost rate. So that'll be 300. And then the very last part says find the current rate of change of sales. So this means we're looking for S prime, rate of sales or sales rate. Okay. So we have everything nicely labeled. So all we have to do is now take the implicit derivative of this equation with respect to time. And the left side, I'll show you how this comes in handy in a second. So let's go ahead and say d over dt of S is equal to d over dt of 50,000 minus 20,000 e to the negative 0.004x. Okay, first part's easy. Implicit derivative of S prime equal to, second part's easy. Implicit derivative of 50,000, 0, minus 20,000. Now here comes the hard part. So we need the implicit derivative of e to the negative 0.004x. And now this is where this side note comes in handy. So we know the derivative of e to the x is e to the x. We know the chain rule derivative of e to the u is e to the u times u prime. But now we are taking an implicit chain rule derivative. So we are going to apply this formula to this e function. So it says the implicit derivative of e to the x with respect to time is going to be x prime times e to the x. So what that says is it's going to be the implicit derivative of the exponent. So we're taking the implicit derivative of negative 0.004x. So the implicit derivative of negative 0.004x is going to be negative 0.0004x prime. And then we multiply by the original e function times e to the negative 0.004x. And there's the implicit chain rule derivative of that E function. It's just crazy, I know. All right. Any questions on that before continuing? Just following that formula. All right. The next thing we're going to do is take this negative 20,000 and just multiply it by that negative 0.004. So we're going to get S prime, and 20,000 times, that's 20,000 times 0.0004 gives me positive 8. So you're going to end up with 8 x prime e to the negative 0.004x. Whew. There's your implicit derivative. Now, plug in x and plug in x prime. Everybody good?
Wait, I'm sorry.
Go ahead.
Oh, okay. See, no, I got it. No, I got it. Sorry.
Okay.
So, it's not a -8?
No, because this was
It's a
negative and that was
20,000,
negative.
yeah.
Gotcha. Okay.
That's exactly what I was going to ask, but I saw the negative.
There you go. No, good question. Watch your signs, right? Okay. So now we will plug in 2,000 for x and 300 for x prime. So we're going to say S prime is equal to 8 times 300 times e to the negative 0.0004 times 2,000. And I'm going to type it in just like I see it on Desmos. And if you're using a calculator, you can type it in just like you see it as well. So back to Desmos. Oop. So right there, 8 times 300 e raised to the negative 0.0004 times 2,000. There we go. And I get $1,078.39. Okay. Which means, again, is that a positive number?
Yes.
Yes. So this means that if we are advertising correctly, then it would make sense that sales would increase. So this means that sales increase. Oof. All right. All good on that before moving on? Okay. Next. All right. 4. The price P in dollars and demand X for a product are related by the equation X equals 7,000 minus 0.1 P squared. The current price of $100 is decreasing at a rate of $5 per week. Find the associated revenue function and the rate of change in dollars per week of revenue. Okay, so once again, let's just label everything we know. So let me do that, sorry. All right. And then we know that, so P is the price in dollars. So P is price. And we know that the current price is $100. But then we know that the price is decreasing at a rate of $5 per week. So this means that P prime, which is the rate of price or the price rate, is going to be -5. And why is it negative?
It's decreasing.
Because we're decreasing, right? Good. And then X is just the demand. Okay, I don't think we need an X prime here. It's not saying anything about the rate of change of demand. It wants the rate of change in dollars per week. Okay, so first up is find the revenue function. Okay, so A, find revenue. Now, if you remember from good old from 1324, revenue is given by the amount of items X times P. So that's just the formula for any revenue function. The amount of items X times the price, P. Okay. Well, based on this problem, did they give us an equation in terms of X?
Yes.
Right? They gave us that X is equal to 7,000 minus 0.1 P squared. So we're going to plug all of that in for X. So this means we're going to get 7,000 minus 0.1 P squared times P. So again, we took all of that and plugged it in for X. Okay, and now just go ahead and distribute the P. And we'll have 7,000 P minus 0.1 P cubed. And there's our revenue function. All good? Okay, which means if we have the revenue, we can find the implicit derivative of the revenue function, which is what B wants. So for B, we're going to say d over dt, and I'm just going to write r because we know it's our revenue function. D over dt of r is equal to d over dt of 7,000 p minus 0.1 p cubed. Okay. Now let's take the implicit derivatives. Implicit derivative of r prime. Implicit derivative of 7,000 p with respect to time is going to be 7,000 p prime minus the implicit derivative of 0.1 p cubed. This 3 comes down and multiplies the 0.1, which means I'll get 0.3 p squared p prime. Okay, there's our implicit derivative. And of course, for my MATLAB purposes, it could also be 7,000 dp over dt minus 0.3 p squared dp dt. All right, I'll just put MML.
I have a question
Go ahead.
before we move on, just real quick. On the negative 0.3 p,
Mhm.
the second power, do we always have to add on like the p prime? Let's say if we're doing the derivative of it.
Mm-hmm. Yeah, because it's always an implicit, so we're always going to need that p prime.
Okay.
If it wasn't implicit, then it would just be 0.3 p squared. But since it's implicit, it has to have that p prime.
Okay.
Or that dp dt, whichever you prefer using.
I mean, I guess like where I'm kind of confused at is why don't we also add like 7,000 p, and then p prime, like one more p. Does that make sense? Like next to it.
Oh, like for this one, right? Why is it
Yeah.
not like p prime, right?
Yeah. Exactly.
Yeah. Because so remember, if we go back to the first page, you'll see that d over dt, and I'll do it for all the terms. D over dt of x is just x prime. And then d over dt of y is just y prime. Therefore, d over dt of p would just be p prime, no matter if you had a number in front or not. So d over dt of 7,000 p would just be 7,000 p prime.
Okay.
That clear it up?
Somewhat, but I guess I'll just keep going. That's fine.
Yeah, it's just the notation. That's it, right? Because if you would have a p prime if you did d over d squared, d over dt of p squared, right? If it was p squared, then it would be 2p p prime.
Okay.
So it just depends on the power of the variable. All right. Okay. And now all we have to do is plug in p and p prime. So C. R prime is equal to 7,000 times P prime, which is -5, minus 0.3, oops, P 100 squared times P prime, which is -5. And I'll just type that into my calculator here. 7,000 times -5 minus 0.3 times 100 squared times -5. And we get -$20,000. So based on this problem, now we have a negative answer. This means that price is what? Or actually, well, this does not mean that price. This
Revenue.
means that revenue is what?
Decreasing.
Decreasing. Because it says the price P in dollars and demand X for a product are related by current price of 100. So if they are decreasing the price by $5 per week, then that would make sense for your revenue to decrease. So we can say revenue decreases. Okay. Any questions on that before moving on? All right, then. Last one, guys. Five, a company's profit from selling X units of an item is P equals 0.3X squared plus $8,000. If sales are growing at the rate of 20 per day find how rapidly profit is growing in dollars per day when 600 units have been sold. So again, we label, and here it says that X is the number of units. And we're saying that we have sold 600 units. And then it says sales are growing at the rate of 20 per day. So it may be a typo, but I'm sure I left the word unit out. So we are selling 20 units per day. That's our rate. So that means X prime is our unit rate, which means we would have 20. And then P is, of course, profit. And we are looking for how rapidly profit is growing. So this means we're looking for P prime, the profit rate or rate of profit. Okay, so that means all we have to do is take the implicit derivative of the given equation above. So we'll say d over dt of P is equal to d over dt of 0.3x squared plus 8,000. Okay. Implicit derivative of P, P prime. Implicit derivative of 0.3x squared. So you're going to have that 2 come and multiply your 30 cents. So 0.6 x prime. And the implicit derivative of 8,000 is 0. There's your implicit derivative. All good? And then just plug in x and plug in x prime. $600 times 20 and 0.6 times 600 times 20 is going to give us 72,000. Which means that's a positive number, which means that if we are selling 20 units per day and 600 units have been sold, this means that profit is increasing. Woo. And there you go, guys. That is related rates.
That was probably the easiest one.
Oh, really?
I think so. Or it might have been because I had already been practicing from the other problems that just seemed easier to me after all those practices.
No, that works. Okay. Other than that, we are done. If you have questions, stick around. If not, go enjoy your spring break. I'm pretty sure you didn't know it was spring break next week.
I completely forgot about it.